to be doing constructions, and hold on. All right, so you know, the father of geometry is Euclid. Remember, we were talking about that at the beginning of the year. He basically wrote the same geometry book we use now. Of course, like, you know, it's in color and in English, but he basically the same stuff he did we're learning about today. And what he did was he used a compass and a straight edge, no measurement tools at all, because you'll notice, like on your straight edge, this isn't a ruler, this is just a piece of wood, right? A straight edge. It just makes a straight line, but it doesn't measure anything. Same with your compass. There's no measurement on here, okay? So if he creates two angles that are identical, it's, you know, he's using those. He's not measuring and measuring those. He's just creating them. Yeah. Oh, right in there in the top bin. No, up to metal one. Yeah. You can just do it in here if you want. It's up to you. Okay. Okay. All right. So what we're going to do is we're going to create equal segments, equal angles, using just a compass and a straight edge. So let's do a really easy one first. Let's do congruent segments. So let's say I want to create a segment that's exactly that long. Okay, so draw on your paper, draw a segment. Doesn't really matter how long, just don't make it really long, because that's just making it unnecessarily annoying to measure. Okay, now let's say I want to construct a segment exactly that long, and I can't measure it. Okay, so what I'm going to do is I'm going to make a line here, and then I'm going to chop it off at the same point as my line. So let's say this is segment AB, and I'm going to create segment CD that's exactly the same length. All right, so what I do is I take my compass and I put my compass right at the edge of the line. Okay, I'm going to make sure you can see it. Does everybody remember that day? Okay, I'm going to put my pointy edge right at the end, and I'm going to basically use my compass as a measurement tool. So I'm going to open it up to the end of that segment, so I know exactly how long it is, and then leaving it open that exact amount, I'm going to move it down here so that the pointy end's right there on the edge of the, and I'm going to put a little, what we call an arc mark, right there. And so basically, I've used my compass as like a measuring tool. I know that this arc is that wide, so I put my little mark there to show that should be the end of the segment, so that's D. So I've just constructed a congruent segment. Does that make sense? Do we need to do that one again, or is that pretty straightforward? Well, we did do a circle circumscribed around a triangle. Remember when we learned circumcenters and incenters? But we didn't really do congruent segments yet. Okay, so that's a congruent segment. Now let's so that's pretty basic. But the idea of it, we're going to be using the whole idea that we're using the compass as a measuring tool. We'll use that all throughout all these other constructions. So let's try a congruent triangle, or a congruent angle first. So let's draw an angle on your paper, any angle. I would start with an acute angle because it's harder to do obtuse. So maybe like that. But any triangles or any angle's fine. Okay? And then what we're going to do, think about in an angle, does it really matter, like, is this a different angle than, say, that, if I just shorten that leg? No, it doesn't matter at all how long the rays are, right? It just matters, what's the one thing you know that matters about an angle? Yeah, how wide it is, how open it is, but the distance between here and here, right? And we have to be careful because if I'm creating a new angle and I measure the distance between here and here, if I go and create that angle and use that distance, but at that point, would that going to give me the same angle? No. So what I want to do with my compass is I want to, first of all, so I'm going to put my point right in the vertex here. First thing I want to do is set in stone the point in the angle I'm talking about. So I'm going to make an arc through both rays. Okay, and then leaving my compass open exactly that amount. I should have probably had to do this first. Draw, like, get yourself started with another bottom ray. And then keeping your compass open that exact amount, we're going to move it over to, again, to the beginning of the what's going to be our vertex eventually. And then I'm going to draw that exact same distance. So because I left my compass open, it's going to be the same distance on both angles. Okay? Yeah, don't try not to do that too much because that's what causes it, people doing that. Yeah, that's why I told you Friday you probably should get your own compass because mine are old and people don't treat them very well. And I didn't buy them because they were awesome. I bought them because they were cheap. So you're stuck with mine if you don't get your own. All right, and then now that we know where we're talking about on the angle, now I'm going to measure this arc that I drew here. So starting from that side of the angle over to that side, I'm going to measure, see how I opened it up exactly the amount of the angle at the arc I drew. So you're going to use, again, you're using this compass as a measurement tool. Okay, once I get it open that exact amount, I'm going to again move it over here, put my point right on the edge here, or on the intersection point, and then I'm going to make a little arc there. And that point tells me that that's how far open the angle is. And then all I have to, how many points does it take to make a line? 2. 1 is the vertex, 2 is that point. So I can just connect those two, starting at the vertex, going through that point, and there's my angle. Okay? And then they look pretty similar, right? And then I can measure it with a protractor. This one is right at the angle, about 10, 20, 30, 43, 44. It's kind of a thick line. About 43, 44. Right? Did I have that? Oh, it would help if I lined that up. So, yeah, like 43, 44. And then I bring it over here and measure it again. Bring it up so it lines up. And see again, 10, 20, 30, 40, 43 and a half, so close. All right? Does that make sense? So why don't you try and create another right angle or another acute angle, and then if you get that right, do an obtuse angle, because that's a little bit harder, but it works the same way. Okay, so using one of those shortcuts, we're going to construct two congruent triangles. So again, you're going to draw yourself a triangle. I would, again, start with an acute triangle because it makes it a little bit easier. And then make one line to start out with over here. So you're going to make a triangle and then a starting line. I'm going to level that out a little more. Okay. Now, if we do side angle side, we're going to first create an equal side. So I'm going to put my pointy edge at the beginning of the segment. I'm going to open this up to be, oops. It's a little bit more, to be exactly the same length. And I'm going to come over here and make my segment same length, right? Now if I'm using side angle side, what do you think my next move is going to be? No, an angle. Right, I'm going to do this angle. So do that. Create this angle over there. And deposit. So I don't need to measure the third side because I have side angle side, so I can just connect those. Go ahead and draw yourself another triangle and try it. Because tomorrow, if we have a pop quiz, I would probably say, like, construct a congruent triangle to this triangle, and I'll give you a piece of paper with a triangle on it. All right? And probably tomorrow I wouldn't measure it with a protractor, but I would look for all the right arc marks, you know? Because I'll give you another day to maybe get your own nice compass, or at least new compass that will work for a couple days. Now we're going to learn how to bisect an angle. What's bisect mean? Right, it cuts it into two equal pieces. So the first thing you're going to do is draw a triangle, an angle, all right, and make it, like, I would leave it acute, but make a pretty decent size acute, because if you make it obtuse, it's hard, and if you make a really skinny acute, it just is hard to manipulate the compass. All right, and remember when we talked about bisecting, like chapter 2, we said to bisect an angle means to find points that are the same distance from both sides of the angle. So remember we drew right angles and we said there's a point. All these are the locus of points that are for the same distance from both sides. Okay, so that's what we're going to do. We're going to create a point that is the same distance from both sides. So you take your compass and put the point on the, we're going to start just like we did for congruent angles. We need to mark a starting point so that we know we're working from the same distance on both sides of my angle. So I'm going to open it up really any amount you want and draw an arc through both sides of your angle, so that we know we're starting from the same distance. This is the same distance and this is the same distance, because basically aren't they radii of a circle? Like if I continued this all the way around, it'd make a circle, and that would be the radius, right? All right, then what I'm going to do is I'm going to start at the bottom intersection point, And let's change colors here. And I can use the same distance, I can use a different distance, it doesn't matter. Let's move, we can move it a little bit, like maybe make it out a little bit farther. And I'm going to mark all the points that are equidistant from that point. Because again, it's just a circle, right? So by making this arc, all the points along this arc are the same distance from this intersection point. And leaving the compass open the exact same amount, I'm going to move up here, put my compass there on the point there on the a second intersection point. And this, remember, we left the compass open the same amount, so it's going to be the same distance. So on this arc are all the points that are the exact same distance from this side, and they're both equal. And now I have this one point represents the point that is the same distance from the bottom intersection point to here and the top intersection point to there. So if I connect them, it should bisect my angle. Oop.